Welcome to you. Having journeyed through space for over 4 decades, the Voyager project explored regions of the solar system never before visited. The garbled information and glitch output triggered tense investigations into the S of these transmissions. Experts discovered anomalies in the space probe's performance as it transmitted enigmatic signals. The question arose, what caused the transmission of this alarming data to Earth? Could the space probe have been tampered with by otherworldly species? To answer these questions, it is essential to understand how the Voyager is supposed to function. Join us as we explore why Voyager is sending back unsettling data. Voyager stands as one of NASA's most successful space missions. Initially conceived as a grand tour of our solar system, Voyager became the longest-running space program and NASA's most extensive planetary expedition. The 2 Voyager probes have explored more planets, discovered more moons, and returned more photographic images from space than any other space mission. The Voyager project traces its origins to the discovery of a rare astronomical event called planetary alignment. This event occurs when several planets gather closely on one side of the Sun simultaneously, happening once every 175 years. In 1964, an engineer from NASA's Jet Propulsion Laboratory noted an upcoming alignment of Jupiter, Saturn, Uranus, and Neptune in the late 1970s and early 1980s. This led to the promotion of the Grand Tour project, initially involving 4 spacecraft with a cost of around $1 billion. Due to cost and technical constraints, the project was scaled back to include 2 spacecraft. Voyager 2 left Earth first on August 20, 1977, followed by Voyager 1 2 weeks later in September. This marked the beginning of an epic journey into the outer solar system. Equipped with 11 key instruments, including cameras, radio systems, spectrometers, and more, the Voyagers provided invaluable data about planets. As of 2013, the probes were traveling at a relative velocity of about 38,000 miles per hour and covering nearly 325 million miles per year. Designed with the potential for interstellar travel, the probes feature a large parabolic high-gain antenna powered by 3 multi-headed W radioisotope generators. These generators supply power to the probes, allowing them to execute trajectory correction maneuvers and stabilize the spacecraft on its axis. In January 1979, Voyager 1 began photographing Jupiter, discovering ongoing volcanic activities on Jupiter's moon Io, a groundbreaking observation. Subsequent encounters with Jupiter provided details about its moons, including Europa, Ganymede, Callisto, and Amalthea. Voyager 2 approached Jupiter shortly after, sending back 177,000 images of the planet and its moons within 48 hours of its closest approach. It affirmed Voyager 1's discovery of a thin ring encircling Saturn, unveiling several new satellites and 2 additional moons, namely Ve and Metis. Leveraging Jupiter's gravitational assistance, both Voyager probes continued their exploration, venturing on to visit Saturn. Voyager 1 reached Saturn approximately a year later, making its closest approach in November 1980, positioning itself just 77,000 miles from Saturn's cloud tops. During this encounter, it meticulously studied Saturn's atmosphere and the colossal moon Titan. The probe unveiled that about 7% of the volume of Saturn's upper atmosphere is helium, while the rest is hydrogen. Voyager 1 also observed high-speed winds on Saturn with speeds reaching about 1,100 miles per hour near the equator. Additionally, the probe captured ultraviolet emissions of hydrogen akin to Earth's aurora lights. The subsequent highlight was the flyby of Saturn's largest moon, Titan. Voyager 1 discovered 3 new moons, Atlas, Prometheus, and Pandora, increasing Saturn's known moons from 12 to 15. Titan was a revelation, boasting a thick atmosphere, marking the first evidence of a celestial body other than Earth having such an atmosphere. Voyager 1's close-up images of Saturn's rings confirmed their composition of countless small particles, showcasing gaps and ringlets. This flyby allowed scientists to calculate Saturn's rotation rate at 10 hours and 39 minutes, based on the careful tracking of the interior clouds. Voyager's visit significantly advanced our understanding of Saturn. The probe sent back around 16,000 images and crucial scientific data from its Saturn flyby. On January 24, 1986, Voyager 2 embarked on its closest approach to Uranus, coming within 5,600 miles of the planet's cloud tops. The probe made groundbreaking discoveries, identifying 11 previously unknown moons of Uranus, including Cordelia, Ophelia, Bianca, Cressida, Desdemona, Juliet, Portia, Rosalind, Belinda, Puck, and Miranda. Voyager 2 studied Uranus's atmosphere and its ring system, uncovering unique features such as a misaligned magnetic field, a helix-shaped magnetic tail, and a cloud hidden by a haze layer. The concentric clouds of Uranus exhibited large amounts of ultraviolet light in a phenomenon called diaw. The probe also conducted a flyby of Uranian moon Miranda, revealing enormous canyons believed to have formed from geological faults. In 1989, after a mid-course correction, Voyager made its closest approach to Neptune, traversing through the Neptune-Triton system. Voyager 2 performed a close flyby of one of Neptune's moons, coming within 25,000 miles. It discovered 2 previously unknown moons and confirmed 6 new ones: Thalassa, Naiad, Despina, Galatea, Larissa, and Proteus. The probe also observed the Great Dark Spot in Neptune's vicinity, a phenomenon that has since disappeared. Experts believe it was a region of clear gas forming into a high-altitude methane cloud deck. In 2006, the International Astronomical Union reclassified Pluto as a dwarf planet, marking a significant moment in space exploration. Voyager's flyby of Neptune in 1989 became a pivotal event as it concluded the exploration of every known planet in the solar system by a space probe. One of the Voyager mission's greatest achievements was the Solar System Family Portrait, comprising the final series of 60 images captured by Voyager 1. This unique series showcased 6 planets from our solar system, marking the first and only time a spacecraft attempted to photograph our solar system in its entirety. Voyager 1 captured this awe-inspiring view beyond Neptune, approximately 3.7 billion miles from the Sun. The mosaic of images portrayed Earth as a tiny dot within a scattered ray of sunlight, providing an unprecedented view of our world and its neighbors. In 1990, as Voyager 1 continued its journey beyond our solar system, mission managers commanded it to look back towards home for the final time, capturing Earth as a tiny dot surrounded by the vastness of space. These images became an iconic representation of the insignificance of our planet in the grand cosmos. The Voyager spacecraft's family portrait offers us a fresh perspective on our world, presenting the scale of the solar system and emphasizing its relation to Earth. This intricate mosaic required a combination of methods to capture individual frames, utilizing various filters and exposures. Voyager 1, strategically positioned above the solar system's plane, took this portrait. Transitioning from its planetary mission, Voyager entered interstellar mission mode, allowing NASA to explore beyond the heliosphere. In March 2013, Voyager 1 became the first spacecraft to enter interstellar space, followed by Voyager 2 in 2018. These probes, moving at 330 million and 310 million miles per year respectively, are the sole spacecraft collecting data in interstellar space. Their insights deepen our understanding of the heliosphere, the Sun's diffused barrier around the planets in our solar system. Voyager 1's entry into interstellar space revealed changes in the plasma environment, detecting increased cosmic rays from outside the solar system. It also captured the vibration of plasma particles, providing the first auditory glimpse of interstellar space. Observations included measurements of changes in magnetic field direction and plasma density in the boundary region, confirming the existence of the heliopause. Hidden on both Voyager probes is a gold-plated audio-visual disc featuring Earth's photographs, scientific information, spoken greetings, and a medley of sounds. If discovered by extraterrestrial life, this golden record serves as a pointer to its source. The medleys include sounds of whales, a baby crying, waves breaking, and a diverse collection of music. Greetings from the Secretary-General of the United Nations, the President of the United States, and children worldwide are also part of this unique record. After over 4 decades of smooth functioning, Voyager 1 began transmitting perplexing signals to Earth. Scientists discovered discrepancies in Voyager 1's articulation and control system readings, vital for antenna orientation and spacecraft positioning. The anomaly raised concerns, prompting engineers to rule out the possibility of alien control. While the notion of intelligent alien tampering is intriguing, NASA asserts that proper operation of Voyager 1 requires a profound understanding of its design, suggesting that any potential alien intervention may be limited in its scope and effectiveness. There is no conclusive evidence of tampering with the Voyager 1 space probe, leaving the possibility open that NASA is withholding details until accurate data is obtained. Engineers are diligently working to diagnose the issue, but new anomalies arising billions of miles away continue to deepen the mystery. After returning to normal operation, Voyager 1 started receiving and executing commands from Earth. However, the mission team persists in investigating system data issues. The attitude and articulation control subsystems seem functional, but telemetry data returns as invalid. Notably, this hasn't triggered the fault protection system, which would normally put the spacecraft in safe mode. Due to the vast distance from Earth, light takes 20 hours and 33 minutes to reach the space probe, resulting in a 2-day turnaround for sending and receiving messages. Susan Dodd, the project manager for the Voyager program in California, acknowledges that mysteries are expected in the later stages of a space mission. The 45-year-old space probe is well beyond its anticipated mission plan, and being in interstellar space, an unprecedented high-radiation environment introduces unique challenges. Dodd expresses confidence that if there's a way for the engineering team to identify and resolve the anomaly, they will. Voyager 1 previously relied on backup hardware in 2017 when primary thrusters degraded, showcasing the probe's resilience. Originally designed to last 5 years, the Voyager space probes continue to operate 45 years after launch, offering invaluable insights into our solar system. To manage diminishing electrical power, the Voyager team prioritizes instruments. Power management processes have led to turning off heaters and other spacecraft systems, leaving only the fields and particle instruments operational. Engineers expect the space probes to continue operating at least one science instrument until around 2025. Voyager 1 remains the farthest probe from Earth and is anticipated to reach the Oort cloud in approximately 300 years, taking about 30,000 years to pass through it. Despite being launched at a higher speed, the New Horizons space probe will not surpass the Voyagers due to their unique heliocentric velocities gained from multiple planetary flybys. The Voyager probes stand out among other space missions, surpassing their expected lifespan and providing crucial contributions to our understanding of the solar system. Voyager 2, still operating normally, continues this legacy. The Voyagers have paved the way for space exploration, and their enduring mission is a source of pride, enriching our understanding of the cosmos. Thanks for watching.